From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
When you get your first large metal 3D printer, you ideally, let's say you map out what success looks like and you have an idea, but it doesn't all happen overnight. So you get the printer and you're doing everything at first, right? You're designing the builds, you're actually running the machine, you're unpacking, you're post-processing. So for me, those 2 or 3 years where we didn't have a lot of technician support and additional manpower, I was working a lot of hours and it was pretty stressful. And I think I made a post about it recently, but realistically, having good teams and having a good team is what drives success in any organization.
That was Ben DiMarco. Ben is a research specialist at the Center of Design and Manufacturing Excellence at The Ohio State University. Before OSU, Ben spent 8 years at Honda R&D Americas as an additive manufacturing process engineer and project leader. He joins the show today to discuss his approach to AM education and the cutting-edge research going on at the CDME. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. And thank you so much for joining the show. I'm excited for the conversation. I've gotten to know you over the last year or so and doing some work together with through the American Makes community, and excited for the conversation today. So I like to begin all these conversations with some context for everyone, where they grew up, what got them on the path of engineering, manufacturing. So let's start there. So,
Mike, thanks for having me on. Great to connect with you again. So those who don't know me, my name is Ben DiMarco. I was born and raised in Ohio, Northeast Ohio. I studied at the University of Akron. My mom was a professor there at the university. And I would say at a really early age, probably 7, 8, 9, 10, she was taking me on campus and showing me the engineering department and some of the labs. And so my mom was a professor and my dad owned his own small business. So he owned a business kind of like Cintas. So he was very blue collar and hands-on, and my mom was very much the brain in the family. So it was a nice balance growing up, to have the ability to go out in the barn, work in the shop. I think my dad bought me a welder for my 10th birthday. So started welding really early, and growing up in that type of atmosphere, my mother pushing me in the school and the studies, and kind of having that North Star being engineering focused, and having my father being one pushing me to be hands-on and really understand the problem, at the spot, at the engine, in the bay, under the car, under the hood, changing our own oils, things like that. So
awesome. And what did you study?
So my undergraduate degree is in mechanical engineering, and I studied at the University of Akron. I was very active in Formula Student SAE in the United States. And so I participated in that program for about 5 years during my 5-year degree. Really, I think that was really within additive and within engineering that opened a lot of different doors early on in my career.
And a lot of people that we've talked to recently, there was a singular class or activity that really propelled them down mechanical engineering or materials or welding engineering. Was there something like that for you? I mean, it sounded like you like to work with your hands. I mean, you were welding at age 10, so it seemed a little bit obvious, but anything specific once you got higher up?
I would say, so I started racing motocross when I was very young. I think 7 years old, I started racing motocross, and I had an ATV and the foot pegs kept breaking off of it. Very high load situation, shear condition, and the foot pegs would shear off. And what we ended up doing was we put a very thick chromoly tube through the frame and redesigned the foot peg. And for me, I was pretty young, right? And so seeing that, and my father and the engineer or the small business owner that was supporting us when we were racing, for me, that was interesting because you usually go and buy something and it performs the way you want it to, but it seems sometimes you have to push designs further, especially when you're in the racing environment or motorsports. you tend to break things more frequently. And I think that specific experience was probably when the light bulb came on for me is, hey, this is something I really want to do, and I want to try to improve products. And I think engineering was really a good avenue for that.
And so kind of after that next transition point, so you get your degree, kind of what are you thinking as you start to wrap up your career at Akron?
So I was actually considering going to law school to be a patent attorney. And I realized at that point I was more motivated by the salary or the dollar amount of law school. And I realized that wasn't the right decision for me. So that's when I took the job at Honda right out of university. And the main reason I'll say one of the main reasons I took the job is they had these after work programs of racing. So for me, racing's always been at the root of a passion. And it's a nice segue for additive. I think it's a great application space for additive manufacturing. But when they gave the presentation to me and said, hey, Ben, we have, this is what you're going to be working on. I was a brake design engineer. So taking some of my experience from a student and transitioning to automotive, I would be a brake design engineer. Oh, by the way, after 5 or 6 p.m., you can participate in these race teams on the company time or on your own time, but the company sponsored them. So for me, I was like, this is a win-win. So that's really, I'll say that put me down that path of racing and starting my career at Honda.
And was Honda's in Columbus, right? In Columbus, Ohio, or?
Yeah. So obviously people know Honda as a global company, but their R&D, I'll say their large R&D headquarters for automotive is in the Columbus area, just outside in Marysville. They also have a large presence in California for the automotive side. Within Honda, I wasn't only in Ohio. I started in Ohio. I spent 6 years there. And then the last 3 years, I was in North Carolina at the Honda Aero facility. And really, that's when my additive focus became 100% of my day job.
Right. And I mean, feel free to answer this as specifically or generally as possible, but kind of generally when you think of like, wasn't the old adage for Honda is like, we want to be all the engines in your garage, like they make all these different types of vehicles. So how does it work in a big company like that in terms of, is it kind of siloed groups that are working together on like a specific product line, or kind of for someone who's never worked in a big company, kind of what is that atmosphere like kind of day to day? Like, what are you working on? And you don't have to get into specifics maybe, but just kind of how's it work?
Yeah, that's actually a fantastic question. And, it probably took me 6 to 9 months of just being there to understand the company culture and how it operated. You're absolutely right. Honda is not only an automotive company, but they have generators and boat engines and jet skis, and lawnmowers, aircraft, right? Most people don't even know that they have the Honda Jet. So I think at the core, a large company like that is you have different groups that specialize in different areas. So even for vehicles, right? So we shared a lot of development with Japan. So we had many weekly calls with Japan at 6 a.m. or 6 p.m. And, we were 12 hours, 13 hours apart. So that was really interesting as a young engineer, kind of having that opportunity to work multi-continent with a large company, but then also working with other, I'll say experts in the field. So in the brake field, we were working with experts like Brembo and Continental and some of these big name brake companies that are in Germany and Italy and other countries. So you're putting together a large puzzle. And I think each of those puzzle pieces are very important. And you as they called them the PIC, the person in charge, right? You're in charge of a specific item or function, and you really had to own it. You owned the design, the cost, how you're going to manufacture it, how you're going to make it. So that was really unique within Honda is they looked at you as the engineer, but you also had to see the big picture. And I think that for me, that created a great foundation early in my engineering career. Does that help answer that question? Yeah,
for sure. And I think that's super useful. When I was, one of my first jobs out of school was working at 3M. So another huge multinational company. And so like you're saying, like just to understand how structures work, you need that 6 to 9 months just to get acclimated and figure out kind of who to talk to and at what time to talk to them.
Yeah. And then also you have language barriers, right? And there's other barriers that you have to learn, and it just takes time to understand how to operate. And that can be difficult, I think. coming out of college, right? Because you have a certain way of learning. You go through school and, elementary, high school, college, and it's kind of all structured. And then you get into I'll say the real world after college. And your first to 6 to 9 months is very fast paced, a lot to learn and a lot to pick up. And I think that's one thing in my new role here that I enjoy the most is working with the students and kind of preparing them in advance of, hey, this is what life could look like after graduation. And for me, that's something I get excited about working
And
at
so,
Ohio State.
yeah, and so let's go into that. So kind of, was it directly after Honda that you went to Ohio State?
So I started Honda has been collaborating with Ohio State for many years. I think 20, I don't even want to put a date on it, but I know both on the automotive side, and I was collaborating some with them when I was on the aerospace side. We looked at Ohio State as a well-known university, and in industry, you look at universities to help you develop product. And I think for us, we had some certain areas where we needed support, or we needed that, I'll say the brain power, the horsepower to get something developed more quickly than we had the people to do it. So I started working with Ohio State in different areas while I was at Honda, developed nice relationships with some folks there. And it was when I was in North Carolina during COVID that I was working for Honda, and we had a family member have a pretty serious health issue. And so that brought us back to Ohio to be with them. And I was working remotely for Honda for a while, and this job came up at Ohio State. And it was a great fit because I could still collaborate and talk and work with the folks at Honda and remain in additive. So in metal additive specifically, which is kind of my passion. And for me, sometimes opportunities are put in front of you that maybe you had on a vision board, or in the future, I want to do this someday. For me, I wanted to get back and work at the university and academia someday. It came about 10 years sooner than I was anticipating. So
awesome. I probably skipped a part of your story, but kind of where was the start of additive for you in your career?
The start, I'll say the first start was in Formula Students. I designed the brake systems for this race car, and they developed this new rule where you're on the brake pedals. So when you drive your car, you touch your gas pedal and your brake pedal every day. Probably don't even think about it. It's just natural reaction. Well, we had to develop these cars that would fit the 5th percentile female and 95th percentile male. So the pedal had to travel like 10 inches of movement. And the big issue was the brake lines. Like, how do you route the brake lines in a race car, and how do you get things there? So I was just brainstorming on it, and I had these fluid reservoirs, and I had to put them somewhere. So I actually designed them into the brake pedal itself and 3D printed them out of polymer and put them in the brake pedal. So it was modular with the pedal. And without additive, you probably could have made it out of sheet metal and TIG welded it or something like that, but additive really nested them nicely into the brake pedal behind the driver's foot in the racing condition. And, it was a design competition, so you were rewarded for being creative and thinking creatively. So that was probably the first time I put my hand on a 3D printed part was 2009, 2010. And it's been alongside of my career ever since then. In the brake design community, we would 3D print cores for these brake rotors. We would 3D print with polymer specifically for mock-ups and layouts and test parts and clips. And then realistically for me, metal additive came into my profession about 4 or 5 years ago. And then the opportunity came up to start the metal additive lab in North Carolina within Honda Aero. And that's, like I said, that's really when the additive became 100% of my job every day.
Awesome. And so, that's a big job and something that I see growing in terms of companies across the country, is having that dedicated additive person in an organization in a location. So how was it kind of being that go-to person, even selecting the machines for a facility, building that out, training people? Like, what was that like?
It was stressful. When you get your first large metal 3D printer, you ideally, let's say you map out what success looks like and you have an idea, but it doesn't all happen overnight. So you get the printer and, you're you're doing everything at first, right? You're designing the builds, you're actually running the machine, you're unpacking, you're post-processing. So for me, those 2 or 3 years where we didn't have a lot of like technician support and additional manpower, I was working a lot of hours and it was pretty stressful. And I think I made a post about it recently, but realistically, like having good teams and having a good team is what drives success in any organization. Having a good team to push an idea or a concept forward. So we started very small at that group in North Carolina. I think there was two of us that were working on the additive, and we were collaborating with Japan. And like I said, having a lot of these late night meetings, and every piece of equipment that we decided that we were going to buy, we made a decision matrix. Performance, cost, function, right? And we ended up purchasing quite a large amount of equipment, and it really allows you to see the big picture of when there's a green field, right? There's nothing there, and you can be creative in what technologies you pursue and where you're looking to go. And so for me, like I said, I don't want to say it was stressful, like it was a burden. It was more than I anticipated. And like those are kind of those roles where they get put in your lap and you're like, okay, you either perform or you flounder. And for me, it was fun. It was a lot of fun.
And how have you kind of translated that over to kind of your day-to-day role at OSU? So can you walk us through kind of what you're doing now and what your principal kind of activities are?
Yeah, so at OSU, we're a research center under the OSU umbrella, the Center for Design and Manufacturing Excellence. And the really interesting part about us is we're staff, right? So we're not teaching classes, but we're impacting students. So what that means is we're encouraged to hire students and employ undergraduate students. So I have about 4 or 5 undergraduate students working for me right now, and I'm training them on equipment. We're working together on projects, crunching numbers, running data, things like that. When I first came in, day one, there was a project that I was assigned to, and it was an America Makes project. And realistically, the first 3 to 6 months, I was in the lab every day, running the machines, making sure this project ran successfully. And I had this industry pace, right, that I was used to at Honda for 9 years of got to meet the deadline, have to make sure we hit our metrics. And I think that's good in this research center, because when we work and collaborate with large companies, we understand that pace. So a lot of us came from industry, and we understand the need within industry for academia to match that pace when possible. Fundamental research and some other areas that we are working in, they may take more time, but some of these excelling industrialization, I would say that's kind of an overall umbrella of what we do every day. And what I'm doing is excelling overall industrialization. And in my role, I'm fortunate enough that I still get to go down and run the printers and work side by side with them as an engineer alongside of these students, and trying to explain to them, what is a DOE, and what is the importance of a controlled experiment, and then also what is the importance of a good part.
For sure. And I got to go take a tour this summer at the TRX. You were kind enough to take me around. So for those who haven't been there, you just want to kind of walk us through, like, what types of equipment do you have there? Kind of some of the types of work you would do, maybe not specific companies, obviously, but like we do materials research or something like that.
Yeah. So the center itself is an advanced manufacturing center, right? So we're not just an additive center. We have a foundry, we have a forming area, we have a welding area, we have a machining and subtractive area. So it really allows us to be vertical in everything that we do. And then we have the additive group, which I'm a part of, that focuses strictly on additive. So within Ohio State University, we have all 7 modalities of additive. So prior to OSU, my main focus was powder bed fusion of metals. I had other work where I've done, FDM and some other areas, but coming here and having all 7 modalities, since I've been here, I've had the opportunity to run a binder jetting project. So running the X1 machine. I've had the opportunity to run a blown powder DED project. So leading these projects of different modalities, I think for both as an engineer as well as a university, it's kind of a unique opportunity that we have the access to those 7 different modalities. again, I mentioned I'm more specialized in the powder bed fusion, and I think that's one of the areas within our additive group that we've grown the most. So since I've been here, we've added 4 new powder bed fusion machines, and most recently, a large format machine. And when I say large format, I'm saying larger than, let's say, 300 millimeters cubed in build volume. And having that in a university setting, I think, is important for the students to understand. It takes more time to operate the machine. It takes more time to turn it over. It takes more powder to run it. Having those kind of large scale, big thinking in a research lab is a really great opportunity.
So if I'm a student at OSU, like how do I find you guys? Is there a kind of a culture of doing research projects during the semester? Like, are you pulling from mechanical or welding or materials? What's that like?
Great question. So anyone who is interested, I'll just say, go to the website, cdme.osu.edu, and there's a contact us tab. I think we get, several random contacts like the art department and other groups that reach out and say, hey, I want to print this unique thing, and can you help us? And we respond to that, we do it. But we have 87 students on payroll right now, and these are undergraduate students, which I think is pretty unique. That's not that we don't want to hire graduate students and PhD students, but we have a lot of faculty. So we have about 100 to 115 affiliate faculty that we work with, and we leave them to work with we don't want to be their competition, right? So we leave them to work with the graduate students and the PhD students. We hire the undergraduate students because, there's 90% or 80% of those students will go work in industry. And so I think we have about roughly 40 different majors that we pool from and work from. And it's more, it's project specific. So we have an electrical group that have electrical engineers, mechanical engineers, aerospace engineers, metallurgy, but we also have business students that work for us. We hired a student in the additive group last year to help us with our kind of overall operations of the additive group. So we hired this student that was more of a business and accounting focus to help us on that side. And he really helped accelerate some of the, I'll say, the metrics that we weren't studying and looking at. And so being able to kind of go tap on those different resources is really, it's really beneficial. So, but realistically, if you're a student, I would say the easiest way is to contact us. We do put job postings out and things like that where we have a specific need. I'll give an example is my colleague, Jacob Rindler. He does a lot of work with the sensing technology. So he has a lot of data analytics students that are working for him remotely during COVID, and they're processing and working on data. And I feel like that's a hot topic right now, is the data analytics. And so we've really been looking for those students, and seeing some of their skills, it amazes me, right? The coding skills that they have, Python, and the ability to process data, things that I just weren't available for me during my undergraduate.
And what's the sentiment around manufacturing like these days on campus? I mean, it seems like, for certainly in the US, kind of the last 30, 40 years, like the excitement around manufacturing certainly hit a low point, but it seems to be ticking back up generally. But do you get that sense? Are people excited about finding careers in advanced manufacturing and 3D printing, things like that?
Yeah, I think when you say the word 3D printing, people get excited. Sentiment about manufacturing in general, like castings and machining, foundry, I don't know necessarily what that sentiment might look like, but our goal is to have a 3D printer on main campus that these students walk by, and they can walk in and just print something, or I don't know. I saw something the other day that in this concept is in these CVS clinics, or a Minute Clinic or whatever, you can like walk in and you can print a gummy bear, and you eat this gummy bear. So I think that kind of creativity is a unique opportunity within the sphere of manufacturing, and having just some random printers around campus. And we've talked about setting up a couple printer farms where students can go, and there is one on campus that they can go and print, but allowing them to actually run the printers themselves, I think that's really a unique opportunity. And we're seeing that, right? You can go on Amazon and buy a printer for $200 or $300 and start running your own projects at home.
Sure. So can you maybe detail or pick a favorite project or a project that you're excited about right now in your work, and either with America Makes or other projects that are going around on campus?
I wish I had a demo part. I can go get one if you want. I've been doing a lot of work with Lattices recently, and that's the project I started on when I came here to OSU, is this America Makes Lattice project, and we finished it in May, and we just submitted a proposal, and we started a new opportunity in December where we're doing follow-on work in Lattices. And for me, like I said, I'm a motorsports guy. I'm interested in these high-strength aluminums, right? And so for me, that's something that gets me excited, is how can we use these lattices efficiently in design? And realistically, the community in the additive community is asking, how do we standardize them? How do you test them? How do you evaluate their performance? How do you inspect them? How do you measure them? All great questions. And those are things that we're trying to solve, because we can print them, and we can print them pretty well. But like I said, the larger, I'll say the community of, FDA or the FAA or these larger inspection bodies, is how do you qualify something, or how do you ensure that it's a good part? And so we're making something new. And I think that for me is something that gets me excited, is characterizing these lattices. And you're multidisciplinary, right? Because you're characterizing the material. Like I said, high strength aluminum is interesting to me, but there's other materials like titanium and other materials that I am interested in. But so you're multidisciplinary, your material science, how does the material weld, weldability, performance, mechanical engineering, the strength and performance in different moding and loading conditions. So we use this 3D digital image correlation, and you get this interesting visualization of the stress strain. And you see compression where you wouldn't necessarily expect it, right? And so seeing that real time, and so that's another area. And now fluid and thermodynamics, right? So performance, increasing surface area, and using them for heat exchangers. For me, this is a really exciting opportunity and an exciting field that we're doing research on, and it's something that just, I think, has an opportunity to grow, continue in the next couple of years.
And so for kind of an end use application, kind of a lattice structure would go into, I mean, you mentioned both the FDA and FAA in terms of, there's the aerospace side. I mentioned like kind of lightweighting, or in satellites or drones or some vehicles. But what about on the FDA side? What would you use a lattice for?
Yeah, so they're using it more for, this is just from my research specifically, is like osseointegration, so integration of the body and growth within the body, and so that porosity. It's interesting when you start talking about lattices, as engineers, we're calling it, this is a lattice or a gyroid or a TPMS, BCC, but realistically, they're controlling porosity for integration of the body, as well as, trying to more closely match the stiffness of the bone. So they're putting, let's think about a hip implant or something like that, which is titanium or some material that's significantly stiffer than bone. And so you can use these lattices to shift or manipulate the strength of the part, which, is a challenge for the FDA. Is like, I look at it as that, someone comes to me with their unique design that they use their FEA software, and they ran some tests, and now they have to say, is this safe for a human? So, whereas when you make it out of a forging, or you make it out of a bulk piece of material, it's a little bit easier to characterize.
For sure. And then you get all the downstream process parts, right? Like you and I could design it. We both have our metal printers. The end result that you do and I do could be completely different based on process details, material mixing, and all of that, and all the different controls in there. So the inspection part is huge, and trying to think about unwrapping that piece for different, whether it's fatigue or bone growth or human compatibility, right? There's so many facets of it.
Like customization, right? I'm not a biomedical professional, but I just kind of, like I said, I enjoy reading some of this topic, but seeing how you can use the lattice for customization, I can see that as an opportunity. Yeah, it's interesting to talk to people in industry as well and learn about this, right? Within Honda, we were automotive, aerospace, mechanical, and now having the unique opportunity to working more with the biomedical professionals, and as you mentioned, the space professionals, aerospace and space professionals, really understanding their unique applications for these lattices has piqued my interest.
And how do you, that's probably a more technical question, but so with a lattice, right, you're typically, you would test some unit cell or a combination of unit cells to, whether it's fatigue or mechanical strength. But with additive, you may replicate those over a given distance or in a 3D geometry where you have 4 or 5 in an implant or in a strut of a drone or something like that. And so do you think of it as just translating like, hey, if I characterize a unit cell, we're good. Like we can extrapolate to build it smaller or bigger. How do you think about it in terms of like finding that starting point of what to test?
It's a great question. We could go down a big wormhole here, so I'll try to contain it as much as possible. I think it's very application specific. And I think a lot of folks in additive use that word like, oh, it depends on the application. But I think it's true.
It's a good engineering answer. Is like, it depends.
Yeah, it really can depend, because you have the lattice and it's attaching to this bulk structure. So the stress concentrations might be higher there. But then as you go longer distance, you have more deflection and displacement. So that can impact it. Realistically, what we're looking at is, tension, compression. We're starting to look at bending and shear, and we're talking about torsion. But it really is application specific. Let's talk about the human body, right? If you think about the hip, again, I'm not an expert, but just think about the loading of the hip. You have running and walking and steps, and so you have compression and tension and bending and all these different loading conditions. So really complex. I think it gets a little bit easier when you're looking at the application of lattices, maybe for a heat exchanger or I'm not saying it's easy, but I'm just saying that like testing in a heat exchanger environment is, a little bit more dependent on the inputs, right, of your fluid and the flow conditions and things like that. But when you're talking about applications to a dynamic environment like the human body, or maybe you have loads, vibration loads. If you're talking about aerospace and space, you could have vibration at certain frequencies. Yeah, it's an really interesting problem. It gets me excited. And so we just had a kickoff for that America Makes project. And every time I go into these meetings, and we have a lot of great advisors in the group, in the community, and always new and exciting questions that I go back and I start looking and thinking and doing more research and just sitting and thinking about it, right? So.
Yeah, certainly. No shortage of things to keep you busy and testing over the next few years.
The big question I've put out there, and not to go on any more tangent, is the simulation and the correlation of your simulation model. So, right, we typically, if we want to test something, we make it out of a bulk material, and we get its, material properties. Well, that's the big thing with the lattices is how do you characterize them? How do you develop those material properties? And then how well do they correlate to your design model?
Yeah. And with additive too, I mean, I'm probably a minority in this view, but I've probably undervalued FEA modeling for additive at its current state because there are so many variables, so many material things you just don't know about. And the computing power required to make a good model is limited. We're in the sense that, hey, I could print 5 different iterations and go test them.
Yeah.
Like that's where I generally lean to. I know eventually you'll get to a point where you can have enough data and enough computing power to give robust models. I've just thought that it hasn't been, the amount of effort you're spending to get there is, especially if you're in industry, just takes a lot of work to get there.
Yeah, and that goes back to your initial question is, how do you test or what do you test? I think that kind of answers that is it's more of a semi-empirical model, right? So you have some simulation and some prediction capability, and you go test it or build it and test it and then refine your model.
Yep.
And that's where I think the when I asked the question to you, is like, well, what's your application, right? Because that loop, that feedback loop might look different for different applications.
Absolutely. So wrapping up, I mean, kind of what else is exciting kind of coming up for the new year for you? I mean, kind of two-part question, kind of what are you excited about? One thing that either from a technology you're seeing, material you're working with for the new year. And then kind of the last piece is kind of as you evaluate your career over the last number of years at Honda and at Ohio State, kind of any piece of advice that you would give people starting their career or kind of getting acclimated, they're trying to understand additive manufacturing. So yeah. Two different questions, but kind of wrap it in a nice bow.
Sure. So one thing that I currently am excited about is, I don't know if you're a Formula One fan or a racing fan, but obviously the Formula One season recently wrapped up and there was a lot of controversy and excitement. And like I said, I think additive manufacturing for me is a really great opportunity to work with the racing community and the motorsports community. And so we're looking for opportunities to partner and to work in the motorsports industry. And so for me in 2022, that's, I'll say in the short term, I'm definitely excited about that. And I've gotten some colleagues here now, they're watching Formula One with me. And, you know, it's fun to just bring new interests and hobbies into the group. So and then being able to leverage the technology. On the personal side, I'm restoring an old motorcycle. I have a 1969 Triumph Bonneville, and some of the parts are really hard to come by. And so I'm excited to use additive to help in that restoration project. There's a good video on Jay Leno and some of these other folks that have used additive in these restoration projects. So it was my dad's first motorcycle, and my goal is to have it done by the end of summer. So that's on the personal side. And then as far as like my advice to, you know, I think the biggest thing is just be nice and be a good person, right? And respect people. And I think that can really carry a long way in your career. I think I said at the beginning, it's just the ability to work in teams and solve these complex problems. I think is really valuable. And for me, that's been the most rewarding part of my career. And is some of the people that I've met and collaborating with them and learning from them, like yourself, Mike. You know, you and I have talked about some of your history when you were over in the UK and just different opportunities that you're given and just taking the most of those and enjoying them and working with the people that you're around and just being a good, you know, genuine person. So for me, that's nothing too technical. Like, you know, it's not like, oh, go study harder or try harder. I think those things can be learned over time, but it's really hard, especially in leadership, is just to have a positive influence on your sphere and be a good person. So
sure.
That might sound cliche in the new year and be a good person, but you know, honestly, I think that for me, that's the biggest takeaway. Is the problems might seem bigger than they are, but we're all people, right? So.
Sure. I mean, you see it every day, and I'm sure you have a lot of different conversations throughout the day with people from industry, and there's certainly people I know and had recent conversations with that aren't those people, and you can tell, and they stick out. And so you want to surround yourself with people that are like-minded on that front.
Yeah, and it's hard too when you work with some of those folks that it's just, you know, it's difficult and it can really take away from the enjoyment of the job. And fortunately, like I said, my mother worked in academia and was a professor, and she's given me some advice. But I feel like having a good mentor as well. So I have one or two mentors that are a couple of years older than me, and one that's 10 years older than me, for both personal with the family side and professional, and being able to go to that person and ask them, hey, how should I handle this situation? Or how would you handle this situation? And having that type of support system to lean on and ask those tough questions, like you said, we've all had those, I'll say, awkward moments in our professional careers where there's just someone that's hard to work with, and it's all case by case. So having that mentor like relationship, or having someone that's a mentor to you, I think has helped me, at least in approaching some of those situations tactfully and professionally, and ultimately creating a win-win for everyone.
For sure. Awesome. Well, I appreciate the time, Ben. Excited to see what comes out of OSU in the coming months and years ahead.
Yeah. OH.
That's right. All All right.
Thanks for having me on, Mike. Great to connect with you again.
Thanks.